The diode will do essentially the same thing to current. Remember, we said that current flows from negative to positive. That's in this direction. Now, I'm going to put the diode in the circuit so that the arrow is in this direction. It shouldn't affect current. Let me make the connection. The bulb lights, so there must be current through it. Now I'll turn the diode around so that the arrow is against this flow. Remember, if current flows from negative to positive, the arrow is against that, so it should block it. Let's see. Making the connection, the bulb doesn't light. So just as the control valve blocked the flow of water, this diode is blocking current. Now I'll turn it back around again. Current flows, and the bulb lights. So it should be obvious then from this little demonstration that current flows from negative to positive. Now remember, when I speak of current flowing from negative to positive, I'm referring to the current that flows outside the power source, or the current in the external circuit. Inside the power source, the battery in this case, current flows from positive to negative. Now this is a very important point, so be sure that you understand it, because later on you'll be using the current in this power source to calculate numerous things. So remember this. Current flows in a continuous path from negative to positive in the external circuit, and from positive to negative in the power source. Now, you should also remember that the requirements for current are a source of voltage and a continuous path through which current can flow. Here are some terms associated with current that you should become familiar with. For example, the symbol for current is the capital letter I. A coulomb. That's a measure of the amount of current. Now, 1 coulomb is this many electrons. Now, of course, trying to count this many electrons would be like trying to count the grains of sand on a beach. It just isn't practical. So we'll rely on meters later on to measure current in amperes. Now, an ampere is 1 coulomb flowing past a point for 1 second. And it's called ampere in honor of the French physicist who discovered this means of measuring current. Now, remember also that current is the movement of electrons. It will cause a bulb to give off light. It will cause a radio to produce sound. It's the force that does the work in radar, computers, and communication. We've seen that when a conductor is placed across a voltage, the voltage will cause too much current to flow and burn up the wire. On the other hand, if an insulator is used, very high and dangerous voltage is required to cause any current. In the next lesson, we'll talk about a happy medium.